So today we're diving into a really interesting topic, and that is tracking the price of the S&P 500 over the years, but we're going to take into account inflation and see how the actual purchasing power of someone's portfolio in the S&P 500 would have changed over the years. And we're going to do all of this in Python. So if you're interested in data science, finance, and coding, this has a mix of all those. So stay tuned. So brief overview, the S&P 500 is one of the most followed stock market indices. It represents the 500 largest companies listed on the stock exchange in the US. So it's a really good indicator of the general health of the US economy and a good metric for used for investing your money. And here's the thing, looking at the raw numbers doesn't always give you the full picture, especially when you're trying to compare the values over time. So inflation actually plays a massive role in how we can interpret these numbers. So it's important to actually adjust for inflation when looking at these. Now in this video, what we're going to do is address that by adjusting the S&P 500 index for inflation using the Consumer Price Index, or the CPI. The CPI is basically a measure that examines the weighted average of prices of a basket of consumer goods and services, so things such as transportation, food, medical care, and so on. By adjusting the S&P 500 with the CPI, we can get a better understanding of its real value over time, meaning that we can see how much the index has grown or shrunk in terms of actual purchasing power. So we're going to jump into the code now. So I'm making a few assumptions, and those are, first of all, you have Python installed on your machine. You have pip installed, that's required for installing packages. You have Visual Studio Code or VS Code installed. No worries if you do not, you can just open Jupyter Notebook from the browser. And lastly, Jupyter Notebook, you actually need to have that installed as well. So what I'm going to do is create a new folder on the desktop, and I'm just going to call it S&P, change my font, S&P 500 inflation tracker. So that's what we'll call it. And then we're going to open Visual Studio Code here using the terminal. Actually open on my other screen. So once that's opened, we can just throw this on here. So that's one way to open it. And there we go. So now we're in Visual Studio Code, and what I'm going to do is inside this folder, I'm going to create a new file and just call it SP500 inflation tracker.ipynb, and that's the Jupyter Notebook extension. So I'm going to import a few packages first. So there's a package called yfinance, that's actually Yahoo Finance. So we're going to do import yfinance as YF. Now, if you don't have packages installed, you can just quickly do that with pip. And in order to do that directly from Jupyter Notebook, you can just add an exclamation mark at the beginning and say pip, or it might be pip3 on your machine, pip install yfinance. And if you press Control Enter and run it, it's going to ask me for an environment. So my Python environment is this. I'm going to use this one, the Miniconda 3, and run that. And it's going to say the requirement's already satisfied. So I'll just delete that line. But you can basically install all packages this way. So I'm going to import a few other things, NumPy, Pandas, and I'm going to import Seaborn for visualization, and import Matplotlib.pyplot as PLT. So run these. Okay, so now we're going to access the S&P 500 data through the yfinance API. So we'll just do yf.download, and then we're going to need the marker of the, or the ticker of the item. So in this case, it's the SPY is for the S&P 500. So for Apple, this could be like AAPL and so on for different companies and so on. So we'll select the start date. And let's say we want it from 1993. I believe that is the first date that yfinance has available. And right now we're in August 2024. What I'm going to do is just get till the end of July, because later on in the video, we'll see that the Consumer Price Index is only available till a month before. So yeah, we'll just go with 31st July, and we're going to want to save this in something like SPY or SPI 93 to present DF. You can just call it whatever you want. And there we go. It's downloaded. So now we could just kind of view the first 5 lines. Yeah, so it has it from basically 29th of January. So actually, not even the 1st of January, the 29th of January is the very first date available in this database. And so we're going to look at some of these columns. So you have the open, the close, the high, and the low, and these are all just the different metrics for that one day. The adjusted close and the volume of trades. So we could, for this analysis, we're just going to pick one of these, and I will just pick the close. It doesn't matter which one you pick, just it's kind of important to stay consistent. It's best to just go with the close, in my opinion. So we'll do that. We're going to do a few things here. So the date here is actually an index. So what I'm going to do is I'm actually going to create a date column and then just call it date equals the index. So what this does is if I look at the data again over here, it's going to create a date column for me. And we'll see why that's important later on, because we'll want to work with the dates separately in its own column rather than having it as the index. I'm going to quickly view the data on a line plot using Seaborn. And then for the X, we want to have the dates. And then for the Y, we want to have the close, like we mentioned. Okay, so this kind of shows us that obviously over time, the value has gone up for the S&P 500, and these are dollar values on the y-axis. Okay, perfect. So now we're going to want to look into the consumer price index and basically find a way to get that data. Now, there's a package, another library called CPI. So again, if you don't have it, you might have to do pip install CPI. I already have it, so I'm going to import CPI at this point. And I am also going to import date time, as we will need it as DT. Let's just run that first. And while that's running, so here's what I'm going to do. I basically want to create a list of the CPIs. And before I actually do that, let me show you this. So the CPI has a method called get. So what that does is you basically, let's see if we can look at the docs, by the way. Yeah, it doesn't tell us much here. But basically you could indicate the year or month. So you could just say, for instance, 2000, the year 2000. And let's see what this gives us. Oh, sorry. Let me just erase that one line. Let's import that one more time. So this kind of tells us that the consumer price index for the year 2000 was 172. And then for the year 2023, it was 304. So that's just basically, it returns a CPI. Now, in order to be able to get it for a specific month, you would need to do something like this. For instance, 2023-01, right? But it actually doesn't work as a string. That's why we imported the datetime object, because we're going to have to create a datetime object here. And the datetime object is basically just, a dt.date. And then, so it's basically the year, the month, and the day. So we could just say 2023-01, or we don't need the leading O, just 2023-11. And so this is going to give us the consumer price index for the month of January. And it only goes as granular as a month. So you can't have it like on a day-to-day fluctuating basis. So if I change the day value to like 20, it's just going to be the same. Whereas if I change the month value, it's going to update. So that's how this works. Now, what we're going to want to do is basically get the CPI for every month from the start of this data set, that is in 1993 in January up to July 2024. Now, in order to do that, what I'm going to do, this is what I wanted to do first. I'll create a list. I'll just call it CPIs. It's an empty list. And then I'm going to create a for loop for year in range 1993 to 2024. I want for the months in range 1 through 13, CPIs.append. Basically, I'll copy and paste this here. So append CPI.get year or month equals dt.date. And then the year will be the year. Basically this over here. Month will be month, and day will just be 1. Doesn't really matter what the day is. And yeah, so what this does is basically from 1993 to 2023, because when you say 2024 as the end of your range, it's actually not going to include that. So it's going to go until 2023. It's going to include months 1 through 12. So always remember the end of your range, just -1 is what gets included. And the reason I didn't include 2024 is because we want to have a separate list for that one. We could write an if statement here, actually, like if, you know what, let's actually do that. We could just say if year equals 2024, then CPIs dot, then I'm going to actually create a for loop here for month in range 1 through 8, because we just want to go up to July. Append this. And then I need just kind of need if year not equals to 2024, do this. And yeah, so we could just have it like that. And yeah, so let's just run this real quick. And then if we did this correctly, so we have between 1993 to 2023, that is 30 years. So 30 times 12 months plus 7 months in 2024, 367. So we would want the length of CPIs, or let's actually look at CPIs first. So we see it's a long list. So we want the length of CPIs to be 360. Hang on there. Okay, actually 31 years. Because it's 2023 minus 1993 plus 1. Yeah, duh. So yeah, 379. That's what we would expect. Okay, so basically that's correct. That's right. Now what we want to do is we want to be able to join this list to our data frame. We want to our S&P 500 price data frame. So we're going to need some labels for this list. So right now this just kind of says 142.6, 143.1, and we know because of the order of this for loop, this first value is January 2023, January 1993. The second one is February 1993, and so on. And the last value in this list would be July 2024. So we want to basically create another list that serves as an index or just kind of a title for what these numbers are. So there's different ways to do this. I'll just kind of create this year-month combos list. And so it'll be one of those one-liner lists. So basically I want to say for year in list range 1993 to 2024. And then for month in list range 1 through 13. So it's kind of like a nested list. And then at the very beginning, I want to have basically a string, formatted string, which would be the year, dash the month with 2 digits, basically, 2-digit significance. Oh, this code needs to be here. And yeah, the reason we have this because we basically want, for instance, January, instead of being 1, we want it to have a leading 0 to be 0, 1. And this basically takes care of that. And yeah, so that is what we need here. And let's actually quickly just run this. I'm going to go to another line here and see what that gives us. Yeah, so this is just so that you have an idea of what this would look like. So 1993-01, 93-02, up to 2023-12. And so we want to have, again, because 2024, we had only 7 months, so we'll do that separately. So we'll say year month combos equals what we already had plus, again, another one of these guys. And then the year, we would just say 2024. We don't even need it to have it in the brackets. And we don't need this list. So instead of a nested for loop, it's just going to be one for loop ranging from 1 through 8 because we want it till July. And yeah, let's try that. Don't want to rerun that part. And now let's look at year month combos. Yeah, so it ends with 2024-07. All right, perfect. So just to double check, running len on this, it gives us 379. So last but not least, we'll create a CPI data frame, which will just be a pandas.data frame where we have the a dictionary, and the first column is year month equals year month combos. And the second column is just CPI, and that equals CPIs. And let's just view CPI DF. Yeah, perfect. That's exactly what we want. Okay, perfect. So now we're gonna go back to our S&P index DF and look at how we can actually join these two together. So the date column here is basically a let's look at the D types. So SPI dot D types. Okay, so it's actually a date time for this date column here. It's a date time object. So there's different ways we could do this. One way I could just think of the top of my head is if we kind of turn this into a string, then we could get the left 7 characters. So we could write a function that gets the left 7 characters and then apply it to this whole column. So one way to do that would be so something like this. So SPI year month. We want to create a new column called year month would be basically the date dot apply something like left 7 characters, and then we would need to define this function. So then we would say this function is going to take some x value, right, or some input value, and so it takes that input and it returns. So what it returns is so it takes the input, it actually turns it into a string first, and then over that, it's going to look into the 0th index up to the 7th index. And it is, yeah, so it'll just return this basically. So let's run that and see if that works. So if we run this again, perfect. We have exactly what we wanted. All right, so now we could actually merge those two data sets together or join them. In Python or Pandas, the function for that is merge. In a language like SQL, it's just a join or left join. So yeah, so we're going to do SPI93 present df dot merge. And we want to merge it with the CPI data frame that we created earlier. And the how would be a left join, and we would merge it on the year month. And we gave both of these similar names so that we could just join that easily. And yeah, let's run that and let's look at this again. So now we have the CPI for the different months. So that is perfect. All right. So what we're going to do is let's actually just keep a few of these columns. We're going to just keep the close, the date, close date, the year, month, and the CPI. Let's actually change the order. So date, year, month, close, CPI, and we should just give this an easier name. We'll just call it DF. And so this is what our DF now looks like. So now we will create a new column in DF. We'll just call it inflation adjusted close. And now this will just be the DF close value. So if we think about it, what we want to do is let's look at it this way. So in July 2024, the CPI is 314, whereas in 1993, in January, it was 142. So basically, if we want to have everything translated into today's dollars, or in as of the time of recording this video in July 2024's dollars, what we would need to do is we would need to divide this, whatever that close number was on that date, divide it by the CPI of that time, and then multiply it by this number of today's value. So we want to just basically grow it by, let's say, 314 divided by 142. We want to factor it by that number, that factor. So hopefully that makes sense. In order to formulate that, we would say just take whatever the close column is divided by the adjacent CPI column, and then multiply that by, so you could either hard code this, or if you want your code to be kind of just to work with any new data set you get, you could say something like multiply it by this. Okay, so hopefully that makes sense. So if you run that, yeah, it's fine. Okay, perfect. So that is done. So now all we need to do is actually plot these. And so we're going to go back to, let's just copy this over here. So we'll paste that. So this is what we had before with the regular close. Now we'll use the inflation. Let me just copy and paste this. Okay, interesting. Yeah, let's see why that didn't work. Oh, because we changed the name to DF. That's why. Okay. So now we have that, and let's actually look at these together side by side. And okay, so I'm gonna create a few labels. So label close, and then just label inflation adjusted close. Yep. And I'm gonna actually, let me just do a few things. So if we increase the figure size, that would be much better. And we'll need one more thing. Let's do the X limit from, or actually the Y limit. Let's do from like 0 to 600. So it shows us the 0 as well. And then perfect. Okay. So now we can look at this in real good detail here. So we purchased like one share of the S&P 500. You can't actually buy one share, but you get me. Like think that you would purchase one value of the S&P 500 index at $100, or it was at like what, $42 or something in 1993. So in today's money, that would have been $100. So basically, if you convert everything to today's money, you've basically gotten a 5x pretty much on your returns. And then you could also like filter like different times and dates. So if you look at, for instance, the 2000s era, and then your right equals to today, or sorry, I didn't mean 2020, 2000, 2024, 731 or 30. So like in the 2000s, you can see the real value, or the value of the S&P 500 in that time's money was like $150, but in today's value, like that 150 would have been able to get you approximately like $280 worth of today's goods. So that's what actually the CPI conversion does here. It's telling you that like with $150 that you had by purchasing one worth of the S&P 500 in 2000, you had something like $280 worth of purchasing power today. Whereas today, after COVID, pretty much, we're at about like 550. If we look at it here, the inflation adjusted close, we're about 542 pretty much. And yeah, so it's basically less than double since 2000. Even though looking at the market itself is like tripled, but in reality with CPI, it's only doubled. So hopefully that was informative to some extent. And let me know if you want to see any other sort of content, or if I had made any mistakes here. I would like to say that there are some downfalls to this approach. For one, the CPI, it's an aggregate measure, and it might not perfectly capture the specific inflation experienced by the individual investors or different sectors of the economy. And then I would say that this analysis doesn't also consider dividends. There is a significant component of the total returns investors get from the S&P 500, so we don't really account for that. And lastly, other factors beyond inflation, like interest rates, government policies, these can also influence the index's performance. Oh, one more thing. The CPI, the S&P 500 itself, it's a composition that changes over time. So companies are added and removed based on various criteria, which isn't accounted for in this basic adjustment. But despite all these limitations, adjusting for inflation is a powerful way to get a more accurate view of historical data. So if you found this video helpful at all, don't forget to give it a thumbs up and subscribe for more content like this. And if you have any questions or want to see more in-depth analysis, drop a comment below. Thanks for watching, and I'll see you in the next one.